The next integration technique we'll cover is using trig substitution. This approach comes in handy whenever you have one of three types of square roots in your integral. The first one is the square root of a squared minus u squared. You also have the option of the square root of a squared plus u squared. And finally, the square root of u squared minus a squared. Here, a just represents some number, like 1, 7, or even 100,000. Our u is a function, like x, 3x squared, etc. If you were to have the square root of a squared minus u squared in your integral, you'd want to use the substitution u equals a sine of theta. Accordingly, you'd end up with du equal to a cosine of theta d theta. Thanks to that substitution, your square root, a squared minus u squared, would reduce down to a cosine of theta. In our next case, the square root of a squared plus u squared, you would want to make u equal a tangent theta. Your du would then be a secant squared theta d theta. And your square root of a squared plus u squared would simplify to a nice clean a secant theta. In our final case, the square root of u squared minus a squared, you would want to use the substitution u equals a secant theta. Now your du becomes a secant theta tangent theta d theta. And your root of u squared minus a squared would reduce down to a tangent theta, which is much easier to work with in an integral. Now let's see this all in action. We'll take a look at the example, the integral of x squared divided by 1 plus x squared squared dx. We'll start off by rewriting this as x squared divided by the square root of 1 plus x squared raised to the 4th dx. And now, alert, we have one of our cases. We have the square root of a squared plus u squared, where u is x and a is 1. Accordingly, we want to make the substitution u, which here is x, equaling a tangent theta. Since a is 1, that'll be 1 tangent theta, or equivalently, tangent theta. Now our du will be secant squared theta d theta. And thanks to that handy substitution, the root of a squared plus u squared, which once again is just 1 plus x squared, is going to become a secant theta. A is 1, so that'll be 1 secant theta, or just secant theta. And now we're all set to plug and chug. That x squared will just become tangent squared theta. The root 1 plus x squared is equal to secant theta. So on the bottom, we just have secant theta to the 4th. Yes, we have a power of 4 there. And then our dx, which is equal to our du, since u equals x, is going to be secant squared of theta d theta. And there we go. Now we can simplify this a little bit. We'll have tangent squared theta on the top. On the bottom, this reduces down to secant squared of theta. And of course, you have a d theta over there to the side. And now, remember, tangent squared theta is the same thing as sine squared of theta over cosine squared of theta. And secant squared of theta is just 1 over cosine squared of theta. So the sine squared theta, cosine squared theta is being divided by 1 over cosine squared of theta. And of course, we have our little d theta hanging out right there. The 1 over cosine squared theta cross out. So we just end up with the integral of sine squared of theta d theta. Now we use a good old trig identity to rewrite this as 1 minus cosine of 2 theta divided by 2 d theta. And when we integrate this guy, we'll get 1/2 theta minus 1/2 sine of 2 theta, all plus c. You can multiply out the 1/2 to get 1/2 theta minus 1/4 sine of 2 theta. And of course, we can't forget the little plus c. What we're after here is figuring out what theta is in terms of x and what sine of 2 theta is in terms of x. Well, to start off with, we know that x equals tangent of theta. So that must mean that theta equals arctan x. But we still have that tricky sine of 2 theta, which, as we know, is sine of theta cosine of theta with that little 2 up front. You might be thinking, wait, we don't know what sine of theta is and what cosine of theta is, but never fear. We have our handy triangle. Oh, that is one interesting looking triangle. And we know that x equals tangent of theta. Let's think about this. Tangent of theta is opposite over adjacent. Tangent of theta is x over 1. So we can just stick an x here and a 1 here. And then our hypotenuse would just be the square root of 1 plus x squared. Because of the whole Pythagorean theorem thingamajigga. Yep. And now we know that our sine of theta, which is opposite over hypotenuse, is going to be x over the square root of 1 plus x squared. And similarly, our cosine of theta, which is adjacent over hypotenuse, will be 1 over the square root of 1 plus x squared. So our 2 sine theta, cosine of theta, will just end up being 2x all divided by 1 plus x squared. Alrighty, let's plug this stuff in. We now have 1/2 arctan x minus 1/4 2x divided by 1 plus x squared, and then all plus c. And let's make that look a wee bit nicer and write it as 1/2 arctangent x minus the 2 here and the 4 here can simplify down to 1/2. And then we'll have an x up top over 1 plus x squared, all plus c. And that's a wrap, folks, for this problem.